Hello students, in today's class we shall discuss about the law of constant proportions or law of definite proportions. In our previous class we discussed the law of conservation of mass and its problems, and today we shall discuss the law of definite proportions and its problems also. So let us see the definition of the law of definite proportions. Law of definite proportions, or it is also known as the law of constant proportions. So this law actually proposed by the Joseph Proust, and he proposed the law as a given compound always contain exactly same proportion of elements by weight. This is the definition of the law of constant proportions. So let us take some examples that justifies this definition. So what this law says that whenever you take any compound, it always contain elements, whatever the elements are present, exactly same proportion of elements by weight. Means whatever the elements are present in a compound, so their mass ratios are always same. And here if you continue it, irrespective of its source or method of preparation. So let us take an example that justifies this statement. Let us take the water. You take the rainwater or take the tap water or take the water that is prepared in the laboratory. So wherever you take the water, whatever the source it may be for the water, the basic molecular formula of the water is H2O. So there shall be no change in the molecular formula. Then here 16 grams of oxygen combines with the 2 grams of hydrogen. Means if you take the mass ratio for this, 2 grams of hydrogen combines with 16 grams of oxygen, and if you simplify it, it is equals to 1:8. Here also the mass ratio of the elements in water is 1:8. Here also it is equals to 1:8. Means irrespective of its preparation or the source, the mass ratio of the elements in a particular compound always remains the same. That is what this law says. Now let us see what are the limitations of this particular law of definite proportions. Limitations. So in the definition, if you observe, here they used the word elements. Elements actually contains different masses. Same element have the different masses, they are called the isotopes. So these isotopes, if involved in the preparation of the compound, then their mass ratio may not be same. So let's take an example here. Means it is not applicable when compound is prepared from different isotopes of element. Example, let us take H2O and D2O, because we know that hydrogen is having the three isotopes, protium, deuterium and tritium. So in the case of H2O normal water, the mass ratio of this hydrogen and oxygen is already we have taken 1:8. Here mass of the deuterium, total deuterium is equals to 4, whereas oxygen is equals to 16, then it goes 1:4. Even though same elements are involved, but the mass ratios are different, because from that element same atoms are not involved, but actually its isotopes are involved. And it is not applicable for organic and inorganic isomers. So if isomers are involved, then also we cannot apply this particular law. Let us take an example. So here C2H6O. So in C2H6O, we know that mass ratios are 24:6:16 for the carbon, hydrogen and oxygen. But with this molecular formula, we can construct two molecules, that is C2H5OH, ethyl alcohol. Second one is CH3OCH3, dimethyl ether. So even though mass ratio of the elements is same, but they are not giving the same compound. They are giving the different compounds. Their nature also, chemical properties and physical properties are also different. So here it is not applicable. Let us take another example, that is ammonium cyanate, which isomerizes into the urea. So if you see these two compounds, nitrogens, two nitrogens here, two nitrogens here, same mass, one carbon, one oxygen, four hydrogens, and here also four hydrogens. Means mass ratio of the elements in both ammonium cyanate and urea are same, but their nature is different. They are not same compounds, even though mass ratio of the elements is same. So let us take another example, that is polymerization of the acetylene. For polymerization reactions also we cannot apply it. So in the case of the polymerization of the acetylene, then we'll get trimerization. Let us take the trimerization. So for trimerization of the acetylene, here C6H6 we get the benzene molecule. And if you take the mass ratio of the acetylene molecule, carbon and hydrogen and acetylene molecule, and in benzene molecule, here carbon 12:1 is there. Here also it is 12:1 because it goes one time, here also one time. Mass ratio of the elements is same, but they are not same compounds. So it is not applicable. That means law of constant proportions are different proportions. Not applicable in all these categories for isotopes, isomers, and organic or inorganic isomers compounds. So let us see now some questions. In this question, AgCl is prepared in a variety of ways. The results are tabulated. They are given on table. So different experiments are given. Mass of the silver 80.24 in the first experiment, where mass of the silver chloride is 106.6. And second experiment, this is the mass of the silver and this is the mass of the silver chloride. And for third experiment, this is the mass of the silver and mass of the silver chloride. Now they are asking us to show these results are in agreement with the law of constant proportions. That means we have to show that the mass of silver and chlorine both remains constant in all these experiments. So let's try to solve the question. So first of all, let us take the sample 1. First sample. Find out the percentage of the silver. Percentage of the silver is equals to mass of silver divided by total mass of silver chloride into 100. Means within this mass, total mass, this much mass of the silver is present. And what is the percentage? That we need to calculate it here. So here mass of the silver is given as 80.24 divided by total mass of the silver chloride is 106.6 into 100. Then this value is equals to 75.27 percentage. Then percentage of the chlorine. Percentage of the chlorine means 100 percentage minus mass of the silver in the silver chloride. So that you will get the 24 point, this is 373. So 24.73 percentage of the silver chlorine is present. So let us take the sample 2. In sample 2, let us calculate the percentage of the silver again. Percentage of the silver is equals to mass of the silver 108.549 grams divided by total mass of the silver chloride 144.207 into 100. This value is also equals to 75.27 percentage, whereas percentage of the chlorine also will give the same result, that is 24.73 percentage. Now let's try to solve the third sample, sample 3. Percentage of the silver is equals to mass of the silver 69.8974 divided by 92.8745 into 100. So this value is equals to 75 point approximately 26 percentage, whereas percentage of the chlorine is equals to 24.74 percentage. So means if you take the first sample, silver percentage is same and chlorine percentage also in all these samples are same. That means these results are in accordance with the law of constant proportions or definite proportions. Let us solve another question. 0.7 grams of iron reacts with 0.4 grams of the sulfur to form ferrous sulfide. Up to here one part. So now if 2.8 grams of iron is dissolved in the dilute HCl and excess of sodium sulfide solution is added, 4.4 grams of iron sulfide is precipitated. Prove the law of constant composition. So let's solve this question here. So in first experiment, 0.4 grams of sulfur and 0.7 grams of iron has been taken. So directly here percentage ratio of the iron and sulfur if we take, that is 0.7 is to 0.4, that means directly 7 is to 4. And in the second part, 2.8 grams of iron is taken. So here mass of iron is equals to 2.8 grams. After this iron reacts with dilute HCl and excess of iron sulfide solution. So 4.4 grams of iron sulfide is formed. So iron sulfide, mass of iron sulfide is equals to 4.4 grams. So in the iron sulfide, both iron and sulfur are present. Here only iron is present. Then if you see this here, 2.8 grams of iron is producing the 4.4 grams of the iron sulfide, means This 2.8 grams iron, if you remove from the iron sulfide, you will get the mass of the sulfur. So mass of the sulfur is equals to 4.4 grams minus 2.8 grams. This is equals to 1.6 grams of sulfur is present. Now let us try to see whether these ratios are like this is same ratio or different ratio. So here iron and sulfur ratios, if you take mass ratios, 2.8 is to 1.6. So we can write in 28 is to 16. Again it is 7 is to 4. So this is also in accordance with the law of constant proportions or different proportions. I hope you all understood this video. If you like these videos, please subscribe the channel, and if you have any doubts, please try to share your information or doubts to the classroompoint@gmail.com. Thank you.